You check the time 40 times before lunch. A glance at your phone. A glance at your wrist. A clock on the wall behind you that you don't even remember installing in your mind, but you always know roughly what it says. For 99% of human history, none of that existed. No numbers. No hands sweeping around a circle. No little glowing rectangle counting down the minutes until your next meeting. And yet your ancestors were never late. They were never confused about the season. They knew, almost to the day, when the rains would come, when the herds would migrate, when a child conceived in spring would be born. How does a species build an entire life around time without a single clock? The answer is stranger, and more precise, than you'd expect. Start with the body itself. Long before sundials or calendars, humans were living inside a biological clock so accurate that modern scientists still study it. Chronobiologists call it the circadian rhythm, a roughly 24-hour internal cycle running in nearly every cell of your body, regulating hormones, body temperature, and alertness. Your ancestors didn't need to consult it. They simply lived inside it. Wake near dawn. Rest near dusk. No alarm required, because the alarm was built into the architecture of their cells. But the body only gets you through a day. Ancient humans needed something bigger. They needed to track weeks, seasons, years. And the tool for that was hanging directly over their heads every single night. The moon was humanity's first calendar. Its phases repeat roughly every 29.5 days, a cycle so consistent and so visible that it became the backbone of early timekeeping across nearly every continent. Archaeologists point to the Lebombo bone, discovered in a cave in Eswatini and dated to around 43,000 years ago, as one of the earliest known examples. It's a baboon fibula carved with 29 distinct notches. Researchers, including anthropologist Francis Thackeray, who has studied the bone extensively, argue the marks align closely with a lunar cycle, suggesting someone was counting moons long before anyone was counting hours. Think about what that means. Tens of thousands of years before writing, before agriculture, before permanent settlements, a human sat down with a bone and a sharp tool and made a record. Not of a hunt. Not of a kill, of time itself. The moon told people when to gather, when ceremonies would fall, when tides would be highest for fishing. But it couldn't tell them everything. A lunar month doesn't divide evenly into a solar year, and for a species that needed to know exactly when winter was ending or when a specific plant would ripen, the sky itself became the next great tool. Enter the sun, and the shadows it casts. Long before the word sundial existed, people were reading shadows on the ground the way you'd glance at a phone screen. Stand a stick upright in open dirt, and the shadow it throws will shorten toward noon and lengthen toward evening, shifting in a way that's remarkably consistent day after day. Archaeologists have found deliberately placed vertical stones, called gnomons, at sites stretching back thousands of years, used to track not just the hour but the season, since the angle of the shortest shadow changes as the sun's path shifts throughout the year. And then there's stone on a scale that's hard to comprehend. At Stonehenge, in southern England, the massive sarsen stones are aligned so precisely that the sun rises directly over the heel stone on the summer solstice, and sets in a corresponding position on the winter solstice. This wasn't a coincidence achieved by accident. It required generations of careful, repeated observation, passed down and refined, to build a structure that functions as a calendar frozen in stone, marking the two most extreme points of the sun's yearly journey. Why would a society without writing invest that kind of labor into tracking a single sunrise? Because for early farming communities, that sunrise wasn't symbolic. It was survival. Knowing the precise turn of the seasons meant knowing when to plant, when a frost was likely, when stored food needed to last through the darkest stretch of the year. A miscalculation wasn't an inconvenience. It could mean starvation. Even earlier than agriculture, though, foraging societies were running their own kind of calendar, one built not from stone or bone but from the living world around them. Anthropologist Richard Lee, in his landmark 1960s research on the Duahonsi people of the Kalahari Desert, documented how deeply time was tied to ecological cues rather than abstract numbers. People didn't ask what day of the week it was. They asked whether the mongongo nuts were ripening, whether a particular plant was flowering, which signaled that certain animals would soon be gathering nearby. Time wasn't a grid. It was a relationship with the land, read fluently, the way you might read a familiar face. This is worth pausing on, because it upends a common assumption. We tend to imagine ancient life as vague and directionless, days blurring into each other without structure. The opposite was true. Their sense of time was often more detailed than ours, just organized around different information. You know, it's 3 p.m. They knew it was the week the rains would break, the season the fish would run upstream, the exact days a specific star would first appear on the horizon before sunrise. That last one mattered more than almost anything else. Across ancient Egypt, the star Sirius disappeared from the night sky for about 70 days each year, then reappeared, low on the eastern horizon, just before dawn. This event, known today as the heliacal rising of Sirius, occurred close to the annual flooding of the Nile, the single most important agricultural event of the year. Egyptian astronomers tracked it with obsessive precision, and it anchored their entire civil calendar. A star, watched patiently for generations, became the trigger for planting an entire nation's food supply. Now picture what this actually required. Not a single genius with a flash of insight, but generations of quiet, unglamorous observation. Someone had to notice the pattern. Someone had to teach it to their children. Someone had to keep watching, year after year, checking the story against reality, refining it when it didn't quite match. This is the part that rarely makes it into the story of ancient timekeeping. It wasn't a moment of discovery. It was a discipline, held collectively, across centuries. So let's reconstruct what this actually looked like, day to day, for a hunter-gatherer band living tens of thousands of years ago. You wake naturally, your body's own clock nudging you awake as light filters through the trees. You don't check anything. You simply know, from the angle and warmth of the light, roughly how much of the morning remains before the heat becomes unbearable for travel. Later, someone points to a fading patch of white flowers on a nearby hillside, a signal, passed down through the group, that a particular root vegetable underground is now at its best for digging. That evening, an elder glances at the moon, now a thin crescent, and mentions, almost casually, that the group should begin moving toward the river valley within the week, because the fish will be running soon, just as they always are at this phase. No one writes any of this down. No one needs to. The information lives in shared memory, reinforced by the sky, the plants, and the animals, checked and rechecked against reality every single day. Here's the counterintuitive twist, though, the part that flips the whole story on its head. We tend to assume that timekeeping progressed in a straight line, from vague and primitive toward precise and modern, with clocks representing the pinnacle of accuracy. But research from anthropologists like James Sussman, who has spent decades studying the Duahonsi and other foraging societies, suggests something more unsettling. Many hunter-gatherer and early agricultural societies didn't experience chronic time scarcity the way industrialized societies do. Their relationship with time was often less rigid, not because they were less capable of precision, but because their survival didn't depend on dividing every hour into billable, schedulable units. The clock, when it eventually arrived, didn't just measure time more accurately. It changed what time was for. It turned a shared, ecological rhythm into something owned, rationed, and increasingly, something you're always running out of. That's the twist worth sitting with. Ancient timekeeping wasn't a cruder version of your smartwatch. In some ways, it was less anxious. The moon didn't send notifications. The stars didn't ping you at midnight. The rhythm was there, constant and patient, and people trusted it because generations before them had trusted it too, and it had never once failed to return. Which brings the story back to you, checking your phone for the 40th time today. Somewhere beneath the notifications and the calendar reminders, your body is still running on the same circadian rhythm your ancestors carried through the savannah and the Ice Age. The clock on your wall is new. The one inside your cells is not. Next time you catch yourself glancing anxiously at the time, it might be worth remembering that for the vast majority of human history, people track time just as precisely as you do, without ever once feeling like they were running out of it. You check the time 40 times before lunch. Your ancestors checked the sky once, and it was enough.